So good afternoon. As society, we're facing the enormous challenge of fighting climate change, and it's impacting all aspects of our lives. We need to switch to electric cars, we need to switch to heat pumps, and most of those measures are targeted at reducing CO2 emissions. But CO2 isn't a whole story. Methane is the second most important greenhouse gas and is responsible for over a quarter of the warming we're experiencing today. Methane is a very different greenhouse gas than CO2. CO2 stays in the atmosphere for decades, whereas methane only has an atmospheric lifetime of about 10 years. So that means that if we reduce methane emissions now, we can have a quick impact on our climate. It doesn't free us from the need to reduce CO2 emissions, because as long as those keep going, CO2 keeps accumulating in the atmosphere and keeps warming our planet. But that need to also do something about methane has now been recognized at the highest political level, with last year over 100 countries signing up to reduce their emissions by 30% by 2030. Methane comes from a lot of different sources. There are landfills, so that's waste degradation, there's livestock, coal mines, and most famously the oil and gas industry, because the gas that we use in our homes today mainly consists of methane, and if that's leaking away, it leads to more methane in the atmosphere. And what we found that's interesting about methane emissions is that often a small number of facilities is responsible for a large portion of total emissions. So looking at an oil and gas field in the United States, researchers found that 1% of sites was responsible for 40% of the methane emissions of that field. These are what we call super emitters, facilities that emit much more than one would expect or than similar facilities do. Now, if we can target these super emitters first, it gives us an easy start at reducing methane emissions. But how do you find out which facility to target if the gas you're looking for is odorless and invisible? Part of the solution is flying behind me here on the screen. This is the Dutch Tropomy instrument flying on an ESA satellite. And with it, we can observe methane from space. So how does this work? What we do is that we look at reflected sunlight. So the light comes from the sun, goes through the atmosphere, is reflected by the Earth's surface, and then goes up to the satellite. And along that light path, light at specific wavelengths is absorbed by methane molecules. They leave their fingerprint or maybe a barcode in the light that then reaches the satellite. If we look at how much light has been taken away, we can now estimate how much methane there is in the atmosphere. And with Tropomi, we can for the first time do this everywhere around the world, every single day, using the measurement concept shown on the right, where we circle around the Earth. And with Tropomi, we have a pretty good resolution on the ground, so our individual observations cover an area of about 5.5 by 7 kilometers. Now that's pretty good, but it doesn't allow you to pinpoint exactly which facility it is that is leaking. And therefore, we're teaming up Tropomi with a number of high-resolution instruments. One of those instruments is the Canadian GHGSat instrument that was developed by a commercial company. That instrument can observe methane from space at a resolution of 25 meters. That's a resolution at which we are able to find exactly which facility it is that is leaking. But GHGSat can only do that for limited spatial domains of about 10 by 15 kilometers. So they need to know where to look. And that's exactly the information we can provide with Tropomi. So with Tropomi, we look everywhere around the world every single day. We find the spots where there is more methane in the atmosphere than we would expect, and then we zoom in with an instrument like GHGSat. And recently we found that also with some instruments that aren't originally meant to look at methane, we can pick up the largest plumes just because there is so much more methane in the atmosphere there than one would expect. An example of that is shown here. So on the left here, we've got the Tropomy Observations from a day in May last year. The rectangles show the individual observations, and the redder they are, the more methane there is in the atmosphere. The arrows indicate the wind direction, and you can see that there are 2 areas where there are plumes in the data. Now we zoomed in on those areas with Sentinel-2, and the results are shown on the right. And there you can actually see very large methane plumes coming off 2 facilities that are connected to a gas transmission pipeline. You can see the pipeline running in the background. Now these are very large emissions. One of them is emitting at a rate at more than 100 tons an hour. And in this case, they only lasted for about a day, because the next time we looked there, they weren't there anymore. Some emissions are much more continuous. An example of that is shown here. So on the left, I'm showing average Tropomi data over 2 years over Buenos Aires in Argentina. And you can see over the city center that there's this red blob of methane. We then zoomed in over the square, that's indicated there as well, with the GHG-SAT observation. And then we found these large emission plumes coming off a landfill in the city center. What's happening here is that organic waste is decaying and it's producing methane in the process. And the emissions that you see here in terms of emission rate are equivalent to about 1/4 of all human-made methane emissions that are happening in the Netherlands right now. So that really shows you that a few facilities have an enormous contribution to the methane emissions we have as humankind. And these emissions are very much preventable. There are ways of reducing these emissions. And we don't just find them far away. We also saw, albeit a little bit smaller than this, for landfills in Madrid. And in the oil and gas industry, we found a lot of emissions that are very easy to fix. A good example is oil and gas leaks in Turkmenistan, where we found over 20 facilities that were meant to be flaring methane, but were instead just venting it. So these are installations that are meant to combust the natural gas that comes with oil production, but instead of burning the gas, the facilities weren't working properly, and they were just blowing the natural gas into the atmosphere. And they're reducing emissions is as easy as relighting the flame. But you can also imagine it's pretty hard for a random researcher in the Netherlands to call up an oil and gas company in Turkmenistan. And this is something that's also been recognized at the international level. And last year, under the flag of the UN, the International Methane Emissions Observatory was launched. And their goal is to form the bridge between the science and the companies, so that based on this data, action can be taken. And that way, hopefully, with this kind of cool science, we can have an actual contribution to reducing climate change.